Welcome to Mystery Science Theater presents Vectors. As you may recall from the movie Despicable Me, a vector is a quantity that has both magnitude and direction. Magnitude is basically a number or a size, and direction, well, that kind of makes sense what direction is. It's the direction that it's going. Some examples of vectors include things like force, velocity, acceleration, displacement. A scalar, on the other hand, is a quantity that has magnitude only. There is no direction associated with it. Examples of scalars are things like speed, distance, mass. They don't have a direction. A vector can be represented as an arrow where the length of the arrow represents the magnitude and the arrow points in a particular direction, which brings us to a description of this vector. For example, it's called this vector A. If this is vector A, we could describe this vector as being partly to the right and partly up. The part of it that's to the right we call the x component of A sub x. The part of it that is up we call the vertical component of A sub y. Notice that between the x and y components of a vector we have a right angle. This forms a triangle, which is a very special kind of triangle. It's a right triangle. So there are some properties of right triangles that we should familiarize ourselves with, and you probably already know this, but let's review it anyway. In a given right triangle, the two sides of the triangle that form the right angle are sometimes referred to as the legs of the right triangle. And then the longest side, the side not touching the right angle, is called the hypotenuse. Now, in a right triangle, if we have one of the corner angles that's known, I'm going to use this one for this example. So let's just call this theta. This is theta. Then the leg that is touching the known angle theta, the corner angle theta, is called the adjacent leg. And the leg that is not touching, the one that is opposite this angle, is referred to as the opposite leg. Now, mathematicians throughout the years have discovered that if you take the ratio of any two sides of a right triangle, of a given corner angle, that ratio will be the same no matter how big or small the triangle is. Ratio is a fancy word for fraction, of course. And so mathematicians have given some fancy names to three of these side length ratios of right triangles. They call it the sine. So the sine of this angle theta is equal to the ratio of opposite over hypotenuse. Cosine of the angle is equal to the ratio of adjacent over hypotenuse. And tangent of the angle is equal to the ratio of opposite over adjacent. Let's say, for example, that I had a right triangle, and let's just call this theta, and let's say this was 4, and this was, this was 3, and this was 5. What's the famous 3, 4, 5 right triangle? Well, then the sine of this angle theta is going to equal the opposite over the hypotenuse, 3/5, or 0.6. The cosine of this angle right here is going to equal the adjacent over the hypotenuse, 4 over 5, or 0.8. And the tangent of this angle theta is going to equal the opposite, 3 over the adjacent 4, or 0.75. So you can see how sine, cosine, and tangent is just equal to the ratio of one side over another side, whether it's the sine, the cosine, or the tangent. Now, we can use this definition of sine, cosine, and tangent to figure out the x and y components of a vector. So again, let's say we have a force vector. Let's say this force is 200 newtons, and it is at a 34-degree angle, like so. If I want to find the x and y components of this vector, how much of it is horizontal, how much of it is vertical, first thing I'm going to do is, of course, I'm going to draw this triangle. So this is fx, the x component of that vector. This is fy, the y component, and where x and y touch, that's where we have our right angle. Now, the legs x and y, those are the components. The original force, the 200 newtons, that's the hypotenuse. The original force will always be the hypotenuse. The x and y components will always be the legs, because x and y is where you get that right angle. So in this example, the angle is touching fx. That means that fx is the adjacent side. So if I want to solve for fx, I have the adjacent side that I want, the hypotenuse that I know. Adjacent hypotenuse means I'm going to use the cosine. So the cosine of 34 degrees equals the adjacent, fx, divided by the hypotenuse, 200. So to solve for fx, I'm going to multiply both sides by 200. 200 times the cosine of 34 degrees equals fx. So in this case, I'm ready to push some buttons on my calculator. So after I make sure that my calculator is in degree mode, it's really important to make sure that your calculator is in degree mode if you're measuring the angles in degrees. There are different ways to measure angles. One of them is degrees and one of them is radians. And if you're measuring in degrees, then your calculator should be in degree mode anytime you're doing sine, cosine, or tangent. In this case, we're doing cosine of 34 degrees times 200. I push the buttons and I get 165.8 equals fx. The unit on this, of course, will be newtons, because remember the original force was in newtons. So there's my fx. That's how much of my vector is horizontal. To find fy, that's the opposite side. So I would do sine of my angle equals the opposite, fy, over the hypotenuse, 200. Multiply both sides by 200. 200 times the sine of 34 degrees equals fy. And I push the buttons again. 200 times the sine of 34 degrees. And I get 111.8 newtons equals fy. Now, an important word about calculators. Some calculators, if I want to do the sine of 34 degrees, I type in sine 34 equals. Other calculators, you have to hit 34 and then you hit the sine button in order to get it. So at my calculator, I use a TI-84 Plus, but if I do sine of 34 degrees, I type it in sine 34, and I get 0.55919, and so on. So try this on your calculator. Make sure it's in degree mode, and then see if you need to do sine button first, and then the 34, and then equals, or if you do 34, then hit the sine button. So if I were doing 200 times the sine of 34 on one of those types of calculators, I would do 34, hit the sine button, and then do times 200. That would be 200 times the sine of 34 if I have the type of calculator where I type in the angle first and then hit the sine button. So make sure you know which type of calculator you are using. Another important property of right triangles is what we call the Pythagorean theorem. The Pythagorean theorem is a relationship among the sides of a right triangle. So let's just have a right triangle going on here. Let's call this the adjacent and the opposite and the hypotenuse, just generically. Okay, and a right angle there, of course. The Pythagorean theorem says that the hypotenuse squared is equal to the adjacent squared plus the opposite squared. So for example, if I had a 3, 4, 5 right triangle, it would say, if this my adjacent here is 4, I would say 5 squared, that's my hypotenuse squared, equals 4 squared plus 3 squared. And I can see this is 25 equals 16 plus 9, and 25 does equal 16 plus 9. So I can tell that 3, 4, 5 is a right triangle. There you go. So you may have learned this in math as a squared plus b squared equals c squared. And that's fine, as long as c is the hypotenuse, that's what it is. It's one leg squared plus the other leg squared equals the hypotenuse squared. That is the Pythagorean theorem. Another thing you could do with vectors is to add them. So if I have a vector here, let's call this vector A, and let's call this vector B. If I want to do A plus B, what I do is I draw A, same magnitude, same direction, there's A. Where it ends, I draw B. So here's A, here's B, and then what's called the resultant vector, this vector right here, this is A plus B. That's the resultant vector. So that's what A plus B is. Now you'll notice, and when we find components of vectors, so suppose I have fx and fy, and I want to add fx plus fy. Well, let's draw fx. Where it ends, I begin fy. So there's fy. And the result is from the start of the first to the end of the last. That is fx plus fy. Or in other words, fx vector plus fy vector is equal to the force vector, like so. And that takes care of just an introduction to vectors, finding components of vectors, and doing the Pythagorean theorem.